In today's video, we're going to look at section 10.1, which looks at interest rates. In this video, we're going to, in particular, be discussing compound interest and simple interest, and then tying those two values together. So we're going to be looking at savings accounts. If you have a savings account and you put money into that savings account on day one, the amount that you put into that account is called the principal or the present value, okay? It's just the amount that you start off with before any interest is accrued. So that will be the principal. Then, over time, you're going to accrue interest, okay? We're actually going to look at annual interest rates, but they may be, when we look at compound interest rates, they may be compounded several times a year, but you will always be given the annual interest rate. And once that interest has been added, you will end up with a future value. So at a particular time, you will have a set value, and that is once that interest has been accrued, and that is the future value. Like I said, interest rates are usually stated as annual interest rates, but the interest has to be compounded. So it's going to be compounded a certain amount of times, normally per year. So it may be compounded, you tend to find 1, 3, 4, or 12 times a year. Okay, it tends to be what we do. But whenever you get an interest rate, it's always the annual interest rate. So depending on how the question is worded, depends on, when we look at compound interest, how many times it will be applied each year. Okay. So let's look at compound interest to start with. Okay. Like I said, compound interest is where interest accrues on interest, okay? That means, let's say that you have an interest rate and it's compounded quarterly, okay? That means 4 times a year, interest is added. If it's compounded quarterly, it's 4 times a year. When you do that, the first time, so after the first 3 months, interest will be added. Whatever the interest rate is, it will be a certain percentage of that principal amount. So the interest will be added. Then in the next quarter, so after 6 months, again, that interest is going to be added again, but this time it is on the principal amount that you had at 3 months. So we had our principal amount at the start, then it accrued interest after the first quarter, then it's going to accrue interest again, but this time you're gaining interest on not just that principal amount that you started with, but also on the interest that you earned after the first quarter. So compound interest, you always earn interest on not just the principal value, but the interest that you have already accrued as well. So that's the main thing to realize about compound interest, is that interest can be accrued on interest. With simple interest, that we will look at later, you only accrue interest on the principal value. So you will get this flat rate of interest that's going to be accrued every single time, let's say quarterly or annually or whatever it may be. It's just going to be that same percentage of your principal amount each time. You're not going to accrue any interest on the interest that's already been added. Okay. To show you how compound interest works, I'm actually going to use an example, and then we can kind of pull some information from that. I'm actually going to use example 1 from the textbook on page 431, so you can follow along there, or you can follow along on this screen. So it says to determine the interest rate per period, this is the first thing we're going to do, determine the interest rate per period for each of the following annual interest rates. So this will look at when we are given that annual interest rate, like I said back here, you are always given the interest rate as the annual interest rate, but it's going to be compounded at different periods depending on whatever the problem is. So you then have to figure out how much interest is accrued per period, not just with this annual rate that is given. So let's do this example. If I have 3% compounded semi-annually. Okay, what does that actually mean? When they say that, what does this actually mean? Okay, 3% is kind of considered to be that annual interest rate. Okay, but we are compounding it semi-annually. So what I'm actually going to do is I'm going to split that 3% into 2 because it's semi-annually. I'm going to compound twice during the year. Once after the first 6 months, once after the second 6 months. So I'm going to split that into 2. So it's 3% divided by 2. Whenever you get one of these, this is the reason that I went through a problem like this, to guide you step by step. Always then put your percentage as a decimal, okay? And then convert back at the end. So that would be 0.015, which means that we have 1.5%, okay? That tells me that every 6 months, so semi-annually, I'm going to accrue 1.5% interest on my initial amount. So let's say in this example, I started out by putting $100 in a savings account. Okay. If they told me at the bank when I deposited that $100 that my interest rate was 3% compounded semi-annually, I would then say, okay, I've got this 3%, but it's compounded semi-annually, which means I've got to divide it by 2 because that 3% is going to be split over 2 periods. So that would give me 1.5% for each period that it's compounded. So after the first 6 months, I'm going to accrue 1.5% interest, which means that my $100 is going to accrue 1.5% interest, which would be $1.50. So now my value after 6 months is going to be $101.50 because I have accrued that 1.5% interest. So after 6 months, after my first period of semi-annually, I've accrued that $1.50 and it's been added onto my principal. Now, after my next 6 months, so I'm now in my second period, they are going to give me another 1.5% interest. But because we are looking at compound interest, I'm going to now accrue interest on this value, not just my principal amount. So I'm going to gain 1.5% on $101.50, which if you work that out, 1.5% of that works out to about $1.52, which means that your new value, once you've gained another 1.5% now on this amount, will be $103.02. So after a year of 3% compounded semi-annually, I would have $103.02. Okay. Let's do another example. Let's say now I have 2.4% interest and it's compounded monthly. Okay. That means that I'm going to accrue interest 12 times during the year. Okay. I get interest on my money 12 times during the year because it happens every month. So, same thing again. I've got to actually figure out how much interest I get each month. Now, I know that my said annual rate is 2.4%. So I take my 2.4% and I figure out how much that would equate to per month. So I divide it by 12 because we've got this compounded monthly. And again, I tend to put it in decimals and then revert back just because it's easier to see what's happening. which would give me 0.2%. So every month I will be gaining 0.2% on my money. Okay, seems like a very small amount. So for example, for $100, I would only be gaining 20 cents for the first month. And then I would gain another 0.2% on my $100.20. And then I would gain another 0.2% on my next amount, and so on. And you do that for the whole year. Okay? So you can go ahead and figure that out for each month. If you think about exactly how we do that, okay, come back to what I just did here. My new amount that I had in my first example after 6 months was the old amount that I had plus my rate times my previous amount. Okay, so let's think about this. My new amount here was equal to my old amount plus my interest rate multiplied by my old amount. So for my example here, it was $100 plus the rate that I had per period. So it was my interest rate per period, which was 1.5%, multiplied by that original value, my principal of $100. Okay. I can actually write this as a formula, and then I can actually extend this so that after n different periods, this is what the amount would be. So for example, if I was compounding monthly, I could actually find out at month 5 exactly how much money I would have. Okay. If we look at what we've got here, this is the same as saying 1 multiplied by that 100 plus 0.015 multiplied by 100. I'm going to pull that $100 out, my principal value. I'm going to pull that out. Multiplied by 1 plus that interest rate that I had per period. Okay, so to get my next value, I take my principal value and I multiply it by 1 plus my rate per period. And that gave me that 101.5. Okay, that $101.50. To get my next value, this 103.02, I took my previous value, 101.5, and I multiplied that by 1 plus 0.015. It's the exact same calculation, except I have taken my old value is now the previous value of 101.5, so I've just replaced it with, instead of taking my very first value, I have taken the next one, the previous one to the one that I'm looking at, and I've replaced that $100 with 101.5. So whenever I'm trying to get my next value, we'll call it our new value, it's always this formula here. My next value is always 1 plus that interest rate per period. So I've taken my annual rate and I've divided it up by however many times I'm compounded it in a year. And then I'm multiplying it by the previous value that I had. So whatever the principal is plus the amount of interest that's already been accrued. Okay. I keep doing this. So to find my next value, I would take 1 plus I times the previous value. To get the next one, I would do the same thing again, and I just keep moving up my values. So what I can actually say is that to get my future value, we'll call it F, after n interest periods, that future value, f, that next value that I'm looking for, is 1 plus I to the n, because I'm multiplying by that 1 plus I n times on my principal value. So I took my principal, I multiplied it by 1 plus I. That gave me my next value. If I multiply by 1 plus I again, it gave me that next value. And I can keep doing this. So to find whatever my future value is after n different periods of compounding, so if I'm compounding monthly, let's say I wanted to find out at the 5th month how much money I had, I could say, okay, after 5 interest periods, my future value would be 1 plus the interest rate per period, so whatever my annual is divided up monthly, what that interest is, to the power 5 multiplied by that principal value, whatever value that I started with. I'm going to go back to a previous example in order to show how you would do this. So let's go back to our example here. I've got a 2.4% interest rate compounded monthly. The question is, let's say I had $100 principal value in my account. So I've got $100 that I put into my account. I want to know at month 7 how much is in my account. So if I've got $100 in an account with interest of 2.4% compounded monthly. Question is, how much do I have at month 7? Okay. So after 7 months, how much do I have in my account? Well, let's go ahead and use our formula. So our future value at month 7 would be 1 plus I to the 7 multiplied by my principal of $100. What is I? I is the interest rate per period. Well, we know that we have 2.4% compounded monthly. So we've already figured this out. My interest rate per period was 0.2%, okay? Because that would be my 2.4% annual compounded monthly, so divided by 12. So I always put it as a decimal, like I said, would be 0.2%, 0.002 to the power 7 multiplied by $100. If you put that into your calculator, you should get $101, and if you round it, because we're looking at money, it would be 41 cents. So that's how much I would have in the account after 7 months with this particular interest rate. All you would have to do if they asked you a different month, so for example, if they said month 4 here, you would just change that 7 to a 4. So that value n is just the number of, in this case, months that we're looking at. We can do one for semi-annually, so let's go back to this example here. Okay, we've got 3% compounded semi-annually. So let's say this time I've got $100 in an account with interest of 3% compounded semi-annually. Okay. How much do I have after 5 years? Okay. Same thing again. Okay, we use our formula. In this case, we've got 3% compounded semi-annually. So that 3% is divided into two different periods, which means that it was 1.5%, like we said before, which is 0.015. N, how many pay periods do I have here? I'm looking at after 5 years. It's compounded semi-annually, which means that I'm compounding twice a year for 5 years. So my N in this case would be 10. Okay, I'm looking at after 10 pay periods here. So N is 10 and my principal value is $100. So you can go ahead and type this into your calculator. And you should get $116.05 if you were to round that up. So in my next example, I'm actually going to try to find the present value given the future value. So I'm trying to find the principal amount that I need to put into an account in order to have a certain amount after a certain amount of time. So I'm trying to find how much I would need to put into an account right now if after 3 years I want $500 in that account and that account accrues 5% compounded quarterly. So let's go ahead and write out our equation and see what we do know and what we don't know. Okay. My future value is $500. Okay. I is my interest rate per period. So I've got 5% compounded quarterly. So each period I'm looking at 1.25%, which is a decimal, is 0.0125. N is the number of pay periods that I'm looking at. So I have 3 years and I'm compounding quarterly. So I'm paid 4 times a year over 3 years, which means N would be 12. And I am looking for my present value. Okay, so I have $500 is equal to 1 plus 0.0125 to the power 12 multiplied by my present value. If you work this out, you should get 500 is equal to 1.0125 to the power 12 times the present value. And then if you divide both sides by 1.0125 to the power 12, you should get that your principal amount is $430.75. So that is how much I need to put into this account today in order to have $500 in there in 3 years' time. Now I want to take a look at simple interest. Simple interest is just interest that accrues on our principal amount. We don't get interest that accrues on interest like we have before with this compound interest. So let me go back to my initial example that I had here. We had the initial amount of $100. After the first 6 months, so because it compounded semi-annually, I got 1.5% interest on my $100, which meant that I then had $101.50 in the account. When I then, at the next pay period, had another 1.5% interest added, it was 1.5% of this amount, not just of my principal amount. So I was accruing interest on the interest that had already been added to the account, as well as my principal amount. Okay? That doesn't happen with simple interest. With simple interest, you just get interest on the principal amount. Now, you may get it multiple times, but it's always just an interest rate on my initial amount. So let's say you start out with some principal amount P. Okay, that's how much you put into the account at the start. Okay, and then let's say that you are given a simple interest rate of R. Okay, now your future value after n pay periods is going to be the principal amount plus, let's talk about this term here, n times R times P. Okay, at each pay period, you're going to get another amount of interest, and it's going to be the rate times the principal value. Okay, so if you are accruing, let's say 1% interest on your principal amount, you will take 1% of your principal. Okay, but you are going to do that n times. So if we're looking at our future value after n pay periods, we would have our principal amount plus our rate times the principal amount n times after n pay periods. Okay, so another way of writing this is 1 plus nr times p. Okay, so our future value is just whatever we started with plus our rate times the principal value, so how much interest we have accrued, and then we do that n times, okay, over n different periods, however long they want you to do this for. Because you are not accruing interest on interest, you are just accruing interest on that initial principal amount. And you do the same every single time you get paid. You just get the rate times the principal amount. So after n pay periods, let's say that you accrue interest monthly, okay? After 7 pay periods, I could say that n is 7 and this is what my future amount is. I have accrued interest on it monthly, but I haven't accrued interest on interest. I am just accruing interest monthly on that initial amount. Okay. Now, with the examples that we are going to do here, this simple interest rate is actually going to be an annual interest rate. It kind of keeps it across the board with what we are doing with our compound interest, where the rate is always given annually. So that rate R, you won't actually have to do anything with it with simple interest. We're just going to look at this annually. So N is going to be the number of years after which you want to see how much money you have in the account. So let's do an example of this. Let's say that we want to see what the future value is after 4 years of investing $1,000 at 2% simple interest. Okay. It will always state if it's simple interest or if it's compounded. Okay, so you won't have to worry about what the difference is. They will always state that for you. So after 4 years of doing this 2% simple interest on $1,000, how much do we get as our future value? Okay, well, we said it was 1 plus n times r times our principal value. Okay, well, after 4 years of investing, n is 4. Your rate as a decimal is 0.02. And then your principal value is $1,000. So if you go ahead, you get 1.08 multiplied by that $1,000, which will give you $1,080. So after 4 years of investing $1,000 at 2% simple interest, that is the amount that we have. So that tells me that every year I accrue 2% on $1,000. Okay, 2% of 1,000 is $20. I do that 4 times. I'm going to accrue $20 4 times, 4 years in a row. So it makes sense that I have $1,080. So simple interest is a lot easier to kind of figure out in your head as well, to double check, because you're not accruing interest on interest. You're just getting 2% every year of that $1,000. 2% of 1,000 is $20, and I do that for 4 years, gives me 1,080. But it's always nice to have that formula, and then you can go ahead and double check if you want, either on a calculator or in your head if it's a simple calculation. What I want to do now is to actually tie together simple and compound interest. And the way that that is done is by using something called the effective rate of interest. Okay. The effective rate of interest ties these two concepts together. It actually tells you, for a compound interest rate, what it's equivalent to as a simple interest rate. Okay, so when we did our compound interest, we had things like 3% compounded semi-annually. Okay, that told me that I was accruing 1.5% interest every 6 months. Well, what is that actually equivalent to? Because when we go back and look at this example, okay, when we did this, you'll see that I ended up with $103.02. Well, that's not actually 3%, okay? I've accrued 1.5% interest twice throughout that year, which ended up giving me $103.02, okay? Which isn't that 3%, but what is that as a simple interest rate? What is that equivalent to? Well, we can now see from this example, because we're using simple numbers, it's equivalent to about 3.02% simple interest rate, because that's how much I've accrued on $100. So it's easy to see with these round number examples. But is there a way of telling exactly what the simple interest rate is for a given compound interest rate? And that is actually called the effective rate of interest. Okay. How do we do that? Well, let's set these formulas equivalent to one another. Okay. My right hand side here is just my formula for compound interest, where I have to compound m times per year. So if I had to compound semi-annually, in this case I would say m is 2. If I had to compound quarterly, I'd say m is 4. I is just that rate like before, the interest rate per period. So exactly the same as before. P is my principal value. On the left-hand side, I have my formula for simple interest. Remember what I'm trying to do here. I'm trying to phrase my compound interest rate as a simple interest rate. Okay, so I'm setting the two equal to one another, so then I can find what that simple interest rate is for my compound interest rate. So I'm trying to solve for this effective rate here. Okay, my left-hand side, like I said, is just my formula for simple interest. I have my principal multiplied normally by 1 plus n times r, where I'm looking at n different periods, so for n years, okay? Well, I'm just looking at for 1 year here, okay? I want to know annually what my compound interest rate is as a simple interest rate. So n is 1 in this case, and then I have it multiplied by my simple interest rate r, and in this case I'm calling that r effective. Okay. I'm then trying to solve for that effective rate. So the principal values cancel out, and I just get that on my left-hand side multiplied by that on my right. And then I can subtract 1 from both sides to leave me with this formula. So in my example, I'm actually going to compare two different savings accounts and see which one would be better. So let's say I'm trying to compare one that has 4% interest that's compounded quarterly, and another one that is 3.9% compounded monthly. And the question is, which savings account is better? Which one would give me more money at the end of the year? Okay. So we're going to compare them by using this effective rate. That's the only way that we can compare these, because we've got two different amounts compounded at different rates. Okay. So what I'm going to do here is I'm going to work out my effective rate of interest for each one. Okay. So for my first one, okay, 1 plus. Now, I is my interest rate per period. So I have 4% compounded quarterly. So I would be the 4% divided by the number of pay periods, which would be 1% for each one, okay? So it would be 0.01, okay? Because it's 1% each time. To the power of m, the number of times that I am compounding in a year, which is 4 minus 1. Okay. If you go ahead and work that out, you end up with 0.0406. So that's equivalent to 4.06%. Okay, so that's my effective rate. That's actually what my annual rate is as simple interest for this account. So 4% compounded quarterly is the same as saying a 4.06% simple interest rate annually. Okay. Let's go ahead and figure out the effective rate for the other account. Okay. This time, my I is 3.9% divided by 12. Okay, my interest rate is at 3.9% divided over 12 periods. So it would be 1 plus 0.039 divided by 12. So that would be my interest rate per period. The number of times I'm compounding in a year is 12, because it's monthly, minus 1. If you plug all of that into a calculator, you should get 0.0397, which tells me that it's 3.97% if it were a simple interest rate. So 4% compounded quarterly is the same as 4.06% simple interest, and 3.9% compounded monthly is the same as 3.97% simple interest. That tells me that my first account is better than my second. I would get more interest out of my first account than I would my second. So this is always a great way to compare two accounts, is to find out what that simple interest rate is for each one. So you turn your compound interest rate into a simple interest rate, and that is what the effective interest is. Just as a heads up, when you do this, they will sometimes, these terms here, the effectively what is the annual interest rate that is compounded. Okay, this is actually what they call the nominal rate. So if you ever see them refer to the nominal rate, it's just the rate that you are compounding over a certain period of time, okay, over, in this case, quarterly or monthly. Okay, so the nominal rate is the annual rate that you are compounding, but we are actually finding what the annual simple interest rate is for each one. So we actually refer to that annual rate as the nominal rate.